Hi, my name is Sarah O'Connor. I'm a native Northern Nevadan and preclinical biomedical researcher. I love being outdoors and doing anything with my dog Ein, hiking, fishing, snowshoeing, or hiking and fishing together. I'm also a huge nerd. I love movies. If I can, I fit a movie quote into a conversation, or even if I can't, I will. I also love making costumes for any event. I attended University of Nevada, Reno, receiving a bachelor's in biology. My dream was to be a wildlife biologist, running free through the fields and developing a nice rosy pigment. Like most things in my life, my timing was way off, and I graduated during the height of the recession. Unfortunately, this meant there was no wildlife jobs to be had, so I spent the next 5 years in mining, working for a gold, silver, and assay company. Fast forward 5 years, and I finally found a job in biology at Charles River in Reno, Nevada. Charles River is an international clinical research organization with an emphasis in preclinical pharmaceutical research. I am a member of the Special Pathology Department with a focus on immunohistochemistry, or IHC, to support toxicology studies. I investigate if new novel drugs cause immune responses, either decreasing or increasing antibodies, as well as looking at if the drug is binding to its specific target. So let's take a moment to investigate how immune responses and IHC work in Dun 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 Science Corner. Welcome to Science Corner. Today in Science Corner, we're going to talk about how your body detects viruses and pathogens in your body. So I have this bad virus that's entered my body. It's floating around. It's killing me. It's coronavirus. It's evil. It's floating around. My body sends out antibodies, and they come along and they bind to this bad cell. And it sends out a signal to the rest of my body to send B cells or T cells or macrophages to come and eat this bad cell, and it kills it and it goes away. So how do I detect this with IHC? Well, in IHC, I have the cell surface. It's my bad cell, and it has an antigen on it. This antigen is specific to a primary antibody. This is what your body is sending out. This could be CD3 or CD4, CD68. These are B cell or T cell or macrophage antibodies. It binds to this antigen, and then to detect it, since the primary antibody is invisible to the naked eye or under a microscope, I have a secondary antibody which comes in and binds to the primary antibody. It has an HRP molecule on the end, and that is bound to by DAB. It's a brown chromogen, and it is what we see under the microscope, this brown, which elucidates this whole complex. And that is how IHC works. Science! IHC and my research helps to develop drugs that save lives. I've worked on cancer, Alzheimer, and Ebola drugs, and I am currently working on coronavirus vaccines. So while I hope you never get sick, if you do, remember, your friendly neighborhood researcher will be there to the rescue.